Hello friends, welcome back. Hey, remember a few weeks ago I was suggesting that AI is never going to be conscious and, I never said we shouldn't worry about it. I said it can still kill us, but I said it can't really have consciousness as we know it because it doesn't feel, it doesn't have a nervous system, and it also doesn't employ logic when it's actually doing all this amazing chat GPT stuff. It's doing statistical probability, Bayesian kind of pattern matching. I don't think I was smug about it. Well, maybe I was a little smug, but I've changed my mind, or I am changing my mind. It's good to change your mind. It shows you're still trying. Okay, I think that there is a way to create AI, even androids down the road, that may well feel things. And as for whether they use logic or stuff, that's not the point here. I don't think they really need it. They're doing just fine without it. But I do think there might be a way, and we're developing research now, quietly, to build a kind of wet wiring robot or AI that may well feel things. So in this episode, we're basically going to talk about the fusion of biology and AI. Enter cortical labs. This is a place where neurons, real, grown from stem cell neurons, are playing Pong. Yes, they are basically fields of neural tissue that are then hooked up to electrodes in such a way that they can play computer games like the earliest game that I ever played, and I think maybe anybody played, which was Pong. These aren't just brain imposters. They start as pluripotent stem cells, and they basically are coaxed into becoming cortical neurons. They don't have myelin, so it's not like a full brain. It's just sort of neurons in a dish, so to speak. And then these electrodes give them a sense of the ball's position. So there's a stimulation of where the ball is. There's a correlation for them. And as they respond correctly, sort of moving that paddle, then connections strengthen in the sort of tissue bed. And this is basically Hebbian learning. This is like what fires together, wires together. You hear that sort of oftentimes said about the brain. When you get a successful trial, then that sort of information pathway gets strengthened. And that's basically how our brains evolved. From being a little baby all the way to being an adult, you're constantly rewiring. And even in cases of sort of radical injury, this Hebbian system seems to like loosen up and get flexible again so that you can retrain your brain to handle things like an arm injury or something like this. So here you have an artificially built system using biological ingredients, pluripotent cells, and they're learning by trial and error in a real world or more real world scenario than say just text manipulation like you have in LLMs. So this idea of basically creating a kind of petri dish, as it were, a Pong petri dish, is very promising because it means that we might be able to take the pluripotent cells, create interlocking systems that are very neuronal in nature, and then program them to learn from real world experiences. And that seems to me to be the ingredients for actual feelings, because now you've got the kind of biological substrate at work that's then being hijacked really for basically digital manipulation. And then we've got another lab called Kaniku, where neurons, again, these are bioengineered, are trained to detect smells. So the idea is they're going to train a neuronal system that basically can be used to detect explosives. They learn patterns, kind of like a little olfactory AI. And then we might be able to create some kind of matrix of this that could be useful for actually recognizing the smell of explosives, just like you use a dog's nose to essentially like sniff it out at the airport. You basically might have a device that's part biological and part digital, and that could be doing this detection. There is actually a wonderful example that comes to mind now where, these slime molds, which kind of grow out. They're really interesting. They're somewhere between a living animal, like a slug, and a plant. They're very strange kind of creatures, and they basically spread out across like a forest floor, and then they consume the nutrients they need there, and when they run out of them, they coalesce into like a slug, and then they move to another place, and then they dissipate again into back into these more single cell type creatures. Scientists have started to use these, and they've actually tried to train them to find the most efficient way through a complex set of problems to get from here to there. And so I've seen some of this online. You might be able to look up some video of it, because they'll do a time lapse on this slime mold moving and going through different kind of pathways. It's almost like a mouse going through a maze. And they're able to solve really complex problems such that, you know, designers of train lines, public transportation in cities are actually using some of their solutions, the slime mold solutions, to actually do city planning, which is kind of an amazing way in which we're already finding this weird biotech combination. So the point of this little part of the discussion is to say that I was committed to the idea that digital on-off systems were not going to be able to feel, and I still think that's true. But if you're designing, you know, digital binary systems like AI, but using some biological pluripotent cells as the ingredients for that process, then you may be able to scale that up, and pretty quickly, into beings that are like the replicants from Philip K. Dick's Do Androids Dream of Electric Sheep, you know, the Blade Runner franchise. That is a combination of the biological and the digital, and so it's a kind of wet wiring system or paradigm. But now the other side of the argument, which I need to sort of take back, is I was complaining that AI can't think logically or doesn't think logically, and then it slowly occurred to me that we don't think logically very often either. In other words, I was sort of treating human beings like logic is the paragon or the paradigm of their thinking. And after being a logic teacher for so many years, I don't know why I didn't realize humans are really bad at logic. We're not very good at it, and we don't do it very often. So to take it as the paradigm case of human thought is already a huge mistake on my part. So in an effort to retract, let's consider this a bit. Aristotle had a dream that we were all walking syllogisms, basically logic machines at all times. But to be honest, most of us don't deduce our way through life, through anything. We're not induction, deduction, abduction machines. What's really happening then? What's really happening is something that a lot of people will call it sort of Bayesian statistics, where you're kind of making gut level predictions. I don't really know if Bayesian formula are the right way to understand this. I think there's something else going on here. But the point is, human beings are using pattern recognition. And the sort of lingo of Bayesians is something we should just include here, which is you can have prior beliefs, pre-commitments that are affective or emotional, and then you have kind of an event or an experience, and then you have to update those priors. And so that's kind of a process of prediction, pattern recognition, probability, and so on. It's not really logical induction or deduction. And I think that that is probably the way that most of us are thinking all the time. That's the kind of non-logical but pragmatic reasoning that people do, and that I think AIs and large language models are also doing. So when I was saying that, you know, they don't think like humans, I sort of want to revise that and say, actually, that might be all we're doing too, is this weird kind of pattern recognition and then prediction about what's coming next. And we've hidden that by also talking about this very rarefied logical system that very few of us use. Instead of doing like a logical argument per se, your brain is basically going like, you know, okay, based on past snacks, this sandwich is going to be tasty. It's a really kind of associational form of thinking rather than a deductive form of thinking. All right, think about it. We don't pull out formal logic to decide if we trust someone's face or even if it's going to rain. We're pattern spotters too, not philosophers at the cafe. Logic is a rare tool. It's like that fancy hat you only wear once a year. Most of the time, we're making good bets, you know, sometimes good, sometimes hilariously off, and then maybe we use logic to correct it. So if you've ever wondered why you don't think like Spock, it's because you're mostly a pattern guessing pro. So if logic is so rare, why did it evolve in the first place? This is a really interesting question. Like, what's the use of logic if we barely go to it? According to Dan Sperber and Hugo Mercier, these are two cognitive scientists, logic evolved not to make us sort of lone geniuses discovering the truth, but rather to help us win arguments and spot cheaters like in the tribe. It's like a kind of a debate superpower, very important in social, not coercion, it is kind of coercion, but it's a gentle coercion. We call it persuasion, basically. Logic is rare because we don't need it very often, but when we do, it's kind of clutch. It helps us plan hunts, navigate alliances, or just convince someone that we're right. Next time you use logic, remember it's your rare evolutionary ace in the hole. But if logic evolved to persuade others, then you might ask the reasonable question, why did listeners trust logic in the first place? And, Dan Sperber and Mercier argued that humans, they evolved a taste for coherence. When someone reasoned consistency, like, last time we followed the river, we found game, then we tended to trust them. That's a kind of social coordination in action. Logic basically builds trust on this view, and then trust builds survival. So you can kind of see this if you think about, let's say our ancestors were like, well, let's follow the river north and we'll be able to find game, and they keep using that on the river where they live. The place where logic gets really interesting is when we say we take that reasoning, that pattern, follow the river north to find game, we take it to a brand new river, and we say, let's apply the same rule to this, a new river. That's a new level of abstraction. And that's where I think pattern recognition needs some kind of higher architecture to help organize it. And I think that's how logic got going. So logic isn't just about repeating habits, it's about adapting patterns to the unknown situation, the situation that you've never been in before. And that's maybe logic's rare power. That's where it shines maybe. When intuition falters and regular kind of pattern recognition fails, then logic can help guide us forward. So to wrap up, it brings me to this question that maybe we'll save for another show, which is why study logic? Why try to become more logical if you can survive for the most part by just being good at pattern recognition, even as human beings? And the logic teacher in me bristles at this suggestion, but I'm comfortable with a certain degree of bristling. So, all right, if you're bristled by this kind of thing, return next week. We'll have a different topic probably altogether, and I'll see you then, and always stay curious.